When we talk about the future of electricity, we talk about AI, machine learning, then electrical vehicles, battery energy storage systems, nuclear power, and renewable power. But one piece of equipment on which all of them depend upon is the transformer. And now, transformer has become a serious bottleneck in the development of power grids. According to US Department of Energy, the demand for transformer has increased by 41% since 2019. So today we'll see why these transformers have become a bottleneck in the development of power grid and why there is a gap between demand and supply of the transformer. Now, as we have seen that the demand for transformer has increased by 41% since 2019. Once it used to be a background component, but now it has become a strategic bottleneck for the global grid. Then what does transformer actually do and why it is so important? It works on the principle of electromagnetic induction, that is, whenever any alternating current passes through a coil, it induces a voltage in another coil with no moving parts. So the principle of electromagnetic induction is the main component of transformer. Then what is the main work of transformer is step up the voltage or step down the voltage. It raises the voltage for efficient long distance transmission of the power and it reduces the voltage for safe levels for homes and businesses. Now why the grid needs so many of transformers? Throughout the grid, right from generation to distribution of electrical power to our homes, we require transformer in each and every stage. For example, in a generation plant, the electricity is produced in bulk. So in order to transmit this electricity from generation to distribution, we require transmission lines, then distribution lines, as well as transmission substations and distribution substations. So in transmission, we have to transmit this power via high voltage long distance lines. So here comes the main work of transformer to step up the voltage and transmit the power. Then it goes to substation, which step downs the power with the help of step downs the voltage, not power, with the help of transformer, which reduces the voltage. And this step down voltage is reached to the consumer, which uses the power. So here in distribution sector, we have local networks that deliver power. Each stage requires the transformer. More demand means more transformers. Now, the new electricity demand, which is driven by AI data centers, which are 24/7 base load power at industrial scale. Then we have electrical vehicles, which are nothing but millions of new distributed loads. Why they are considered loads? Because they require power to charge the batteries. Now we have industrial electrification, where heat pumps, hydrogen plants and manufacturing plants are working. Here also there is a huge demand of electricity. We have renewables where solar and wind are connected in the grid. So here also we require transformer. So it is estimated that global electricity demand is going to grow by 3.6% in 2026 and 3.8% in 2027 because the data centers are the structural drivers. Now why can't we just make more transformers? So every transformer requires specialized materials and skilled labor, none of which can be scaled quickly. Now let us see what are the materials required to manufacture the transformer. First is core steel, that is grain oriented electrical steel is required to manufacture the transformer, which has limited global supply. Then we require copper and aluminum windings, which are volatile in prices. Then we have insulation, bushings, and oil for insulation and cooling of the transformer. These are the specialized components with long lead times. Then list but can be the skilled labor. We have to give years of training to the laborers in order to become a good manufacturers of transformer. Then what is the transformer supply chain problem? Let us see. First, the distribution transformers have 1 to 2 year plus lead time. Then the larger power transformer can take 3 to 4 years of lead time, which are custom engineered, which are manufactured according to the needs. The utilities are competing for the same constrained manufacturing capacity globally. So as we have seen, there is 41% demand surge, and the utilities are competing for getting the transformers manufactured according to their needs. So what happens whenever any transformer fails? Because of any fault, there can be overheating, insulation damage. Then this may result into a larger fault, which may cause outage, and we require the replacement of the transformer. What are the immediate impacts of transformer failure? That is localized or widespread power outage can be seen. Then we need to procure the transformer immediately at premium cost. Then regulatory scrutiny and penalties can be imposed on the utility. Then what are the long-term risks? Aging of the transformer fleet with no spare inventory. Then no quick replacement can be seen because of no spare inventory, and grid stays vulnerable to many more power outages. Then proactive asset management becomes critical. Then why AI, solar and EVs are making it worse? That is the problem of transformer procurement. Now the AI data centers are nothing but a massive 24/7 base load. Then the solar and renewables are new generating connection points which require again the transformer connections. Then we have electrical vehicles, which are nothing but millions of new distributed loads which require transformer. Then we have industrial electrification such as heat pumps, hydrogen plants and manufacturing. Each and every this stage requires more and more transformer. So every driver adds the load. Each trend independently strengthens the grid. Together they create unprecedented demand for distribution infrastructure, that is the distribution transformers. Grid planners must account for compound demand. So this demand for transformers is getting compounded because of more and more AI data centers are coming up. Then we are installing more solars and renewable power. We are procuring more and more electrical vehicles. Then industrial electrification is happening faster. Now what India and the world is facing, that is 6.4% annual demand growth has been seen in energy sector. Then the distribution of electricity is continuously expanding. We are also integrating renewable energy such as solar and wind, and new grid connections are coming up. Then we have electric vehicles and data centers coming up with no load categories demanding localized transformer capacity. Then we have domestic manufacturing and scaling of local production to reduce import dependency. So we have to incentivize the domestic manufacturing in order to reduce import dependency. Then why the transformer are required in the future? The transformers of the future should be digital monitoring, such as real-time condition data and predictive maintenance can be done with the help of digital monitoring of the future transformer. Then we have advanced materials such as amorphous steel, improved insulation for longer life of the transformer. Then we need to have a smarter grid integration which is designed for renewables, storage of power and bidirectional flow of the power due to integration of renewables. So we can say that the future of electricity may be digital, but it still depends on copper, steel and insulation, that is the transformers. So in this video we have seen that why transformers are becoming bottlenecks and how we should deal with the problems of this high demand of the transformer. Thank you.